Hello everybody, welcome to Build or Buy. Today we're going to be talking about our build specs, and our perspective on this is going to be, if I were building a computer, this is what I would recommend. Now, for those that want the short answer, based on new developments from AMD, which we consider bang for the buck, we would strongly suggest going with the new 550 chipset. We're going to show you some links. We're going to have that information that we'll put in the links on this video, so you can click through the 1, 2, 3, and so you'll know where we're at and you'll understand where we're coming from. And our perspective on this is all about resource management. What's available? What can I do? Do I build a computer or do I buy a computer? Can I build a computer that's better? Absolutely. But can I build a computer that I can upgrade to some extent based on the chipset? Now, based on the 550 chipset, you build a computer, you're going to be limited in what you can do. We'll show you in a minute. That's the short answer. If you want a better machine, we're going to suggest the high-end desktop. And what that includes, that's all inclusive, specifically the X399 chipset. And again, for the short answer, if you want all the bells and whistles, we would strongly encourage the high-end desktop on the TRX40. Now, the distinction of all those, again, it's all about PCI Express resources. So we're looking at PCI Express 3, we're getting into PCI Express 4. A good example is like the Glowtrends Palace card. We've just done the Sky, and the standard by which we judge all these M.2 NVMe cards is the Asus HyperQuad by 16 card, which requires generically a high-end desktop. So we're going to show you some links. Let's go through that. We'll go through the 1, 2, 3, because it's all about when something new comes out, or if you're just looking, you're trying to figure out where to go, it's where do you start. So we're going to look at AMD. We're going to start with the processor. And we're not going to talk any more about the processor, because we're then going to go to the chipset, and that's where the meat of it is. Because whatever you build, for what we're going to recommend is your foundation, is your chipset. Get a motherboard with the chipset you need that you want. Get a processor that will get you on the platform, and then get just enough RAM in there to do what you need, because RAM, motherboard, and processor make up the heart of the computer. Everything else is up for discussion. Most of that's pretty generic. Some of that will depend upon what's available. Some of the things we recommend may or may not be available. For example, a power supply. We used to recommend EVGA. Wouldn't recommend that now. Only two brands we would go with, either the Seasonic or the Superflower. Superflower is now making their own. And again, it's about what's available, maybe not necessarily what you need. Generically, the power supply we're recommending is what we've always recommended, and that's a 750 watt. That'll do for what most people need. But if you can't get it and you have to get bigger, then you have to go bigger. Go bigger or you don't build. So now let's take a look at some links. We're going to go to the computer, and we're going to go 1, 2, 3 through these links. And again, we'll have all those links up on the description of the video, with the latest releases on the processor. Now, this just came out from AMD. We're looking at their latest processor, but again, we're going to the chipset because that's what matters. So whatever processor we use, we're going to show you an easy way to pick that based on the motherboard, because the motherboard with the chipset is the most important. That's your foundation. So we're looking at the AMD Ryzen 3000 XT series processors. And what's important to note, we are looking at processors that are 6, 8, and 12 core. It's the Zen 2 architecture, and what we want to find, drop-in support. These new processors will boot into any AMD Ryzen desktop 3000 ready motherboard BIOS. Let's scroll a little further and look at the chipset. We see the processors, of which there are 3. We look at the cores. They're going to be available July the 7th of 2020. That's fine. Motherboards we're going to look at with the chipsets may require a BIOS update. We'll get to that in a minute. We can go to more articles, but I'm just going to cut to the chase and take you to our links. And I've got this organized with the new Ryzen 3100 and 3300X processors. Now, as we go through the processors, what we're looking at is the new B550. The B550 chipset is PCI Express 4. Anything that's PCI Express 3, I won't call it a dinosaur, but it's still extremely important with PCI Express 4 that we have the resources. So that's what we're trying to look at, because there's 2 chipsets in this lower end that I would consider. One is the newer one, and then the other one, which is really a higher performance chipset, but it doesn't have the resources. We're going to look at that. Okay, with the B550 chipset, let's see what we've got. We've got 20 PCI Express 4.0 lanes with a 3rd generation Ryzen processor, and up to 10 PCI Express 3 lanes. Okay, what can we do with that? Let's think in round numbers. First of all, your video card requires 16 lanes. That's 16, 17, 18, 19, 20. That's 4 lanes. Those 4 lanes can be used for one NVMe drive, because each NVMe drive, whether PCI Express 3 or PCI Express 4, requires 4 PCI lanes. So with this spec, one video card, one NVMe drive on the motherboard for PCI Express 4. This also shows us what the X570 chipset can do as well. And if you'll notice, it shows compatible. We're looking at all the way to the end, compatible, compatible. We don't really get a sense of performance, so what we're going to need to do is look at the X570 chipset and see what it has resources-wise. Let's take a look. So we'll go over to links, and I'm going to keep these numbered like this, 1, 2, 3, 4, so you can see where we've gone, what we've done. So as we look at this, for the Ryzen 3000, this is an X570 chipset motherboard, and this tells us we've got 16 PCI Express 4.0 lane. Okay, we'll stop right there. Again, 16 PCI Express 4.0 lanes means one slot that's 16 lanes that can do one video card. Beyond that, what else do we have? I don't see anything about PCI Express 3. So what we'll have to do to drill further is to go look at some of the motherboards. So as we go through this, the X570 or the B550. Right now, my money would be on the B550. But again, as anything, all this stuff we look at, the specs, we don't know it until we do it, and we'd have to try one, we'd have to build it. Now, would we build one based on what I know? No. Because of what we know and what we're going to show you as we get through this, this is not the place to be. But if somebody needs to build a computer and they say, I don't need everything that a high-end desktop offers, or I can't afford it, I want to show you how to make it affordable. Because again, it's getting on the platform. Other things around can be changed, added, or upgraded, and I want to go through that. But if you want to stop here, I would go to the B550, but we'll need to go through some motherboards. So let's take a look. Okay, the next link I'm going to show you, link number 5. And this is where it gets interesting because now we're going to a place called PCPartPicker. I want to thank our subscribers who mentioned this. I won't mention any names, but you guys know who you are, and it was a great idea. Now, what I'm going to show you is not bulletproof, but it's a good place to start, and I'm going to show you why it's not bulletproof. But you can start there, you can do some what ifs with some numbers, and that's what we're going to do. With these links I've got, it'll take us right in and show us what we need to see quickly. So this is the blank, clean PCPartPicker build list. I've got another link that's already got a URL set to it that'll take us into the things we want to go to expedite the process. But as you look through this, you pick through the CPU, the cooler, the motherboard, memory, yada da da da, all the way down the line. So as we pick these components, it allows us to choose components that are compatible with each other, so we're less likely to get the wrong things. It makes the research of the resources faster. So we'll go to the next link, and we will do choose a motherboard. And the motherboard we're going to be looking at is for the chipset B550. Okay, now here's where it gets interesting. We're looking at the B550. We have 44 motherboards. We make one little change and it changes everything, but it's not a valid change, and I'm going to show you why. Stay with us. Okay, as we look at 44 motherboards, if I were to change one item on here, and I'm going to say, again, choose a motherboard, and I've changed that one item to say, and this is an impossible choice, but I just want to show you what I mean. It's about resources. Watch. Let's go over here on the left-hand side. We're going to go down to PCI resources, and we're going to look at PCI Express. Okay, PCI Express by 16 slots. If we were to choose 3 slots, this link will now tell us that there are 7 compatible motherboards. It's impossible. The B550 does not have 3. It doesn't even have 2. It's only got 1. This is the example of some of the problems you just need to be aware of. You need to know what you're looking at and what you're looking for. So then once we get to a certain point, we can drill down. So I'm going to go back and show you what I'm talking about. Okay, since we know that is not true because it's not possible, we can go back and look at our resources on the motherboards. The B550 chipset supports 20 PCI Express 4.0 lanes. And the other chipset, which is the X570, is 16 PCI Express 4.0 lanes. So you see by the nature of the spec, PCPartPicker is great, but if you make a wrong choice, it lets you make that wrong choice, and you just have to be aware that that's a problem. So go back to the specs, we'll go back to our links, we'll go down to the next link, and what we're going to do is go through the process of looking at the motherboards. So as we have picked a motherboard, we're going to pick the first one, which is the Gigabyte B550 AORUS Pro, and we'll go to Gigabyte's site. We can get an idea of the price. Now, what we're after, typically we can go to the manufacturer's website, look at the specifications, and it will tell us what we want to know about resources. Right now, for whatever reason, Gigabyte is making that a little bit more difficult to find. It's easy to find on the Asus site, and I'll show you. So what we need to do is download the manual, look at the manual, and it will show us the slots and the way they're laid out. So that's what we need to do next. So we're going to look at the specification, CPU, chipset, memory, onboard graphics, audio, LAN, wireless expansion slots. We have one PCI Express by 16 slot integrated with a CPU. We have one PCI Express by 16 slot, which is actually a PCI Express 4-lane slot. One PCI Express by 16 slot integrated in the chipset, which is PCI Express 3.0 by 2. So that gives you some idea of the reality of the resources. But again, let's look at the motherboard manual, and it'll have the specificity that we need. Support, manual, and we will pull that manual down. Now, I think it's going to be appropriate while we're talking about PCI Express slots. Let's also keep in the back of our mind about memory because, well, I'll show you what I mean. Okay, we have 3 slots that are mechanically by 16. And as we've read the documentation, we've got one 16-lane slot. Let's go back over here, look at it again. We have one PCI Express by 16 slot. We have one PCI Express by 4 slot. And we have one PCI Express by 2 slot. So you don't have a whole lot of resources there to work with, which is on the B550 chipset. So it's there's not much you can do there to add stuff. You can't add something that requires, say, maybe an 8-lane slot. You're kind of hosed on resources. So I know what the chipset does, but I see what the motherboard says. And even though the chipset has a spec, this is what we're seeing, and that kind of stinks. So what we're looking at again is one video card that's 16 lanes, PCI Express 4, that you're probably not going to be able to take advantage of because we need a PCI Express 4 video card. And you're not saturating the bus with PCI Express 3 anyway. But anyway, that's another story. So you're going to have one video card in that top slot, and then the other 4 PCI Express 4.0 lanes will go to one NVMe drive, which from a resource standpoint kind of sucks. So I know what the spec says, but this is what the motherboard shows. So let's take a look at the other one, compare with the X570 and see what we've got. So what we need to do now is just to verify those specs because we've looked at one motherboard, one brand, one manufacturer. Let's look at another motherboard, same chipset, this time by Asus. It'll be a little bit easier and a little clearer. We won't have to download the manual. We can look at the specifications for that particular motherboard, and then we can compare the two and we can get a better idea if they're all going to be like that. So stay with us. Now let's take a look at an Asus motherboard, same chipset. All right, this is an Asus Republic of Gamers Strix B550 Gaming. And we will be able to tell from the specifications, CPU, chipset, memory, graphic, GPU support, and expansion slots. Now this is what you see with most of the systems as everybody asks about our perspective on the Asus HyperQuad by 16 card. So that's our perspective on building a new computer. If you build a computer, can you put one of those in your machine? Probably not. And I want to go with you on the back and forth of, well, I can't afford it, but yes, you really can because we want to show you how to make it affordable. It's just let's talk build specs before you build, and that's what we're trying to do right now to help you with. So again, on the Asus board, we've got 2 PCI Express 4.0 by 16 slots. 1 by 16, or the 2 together, is by 8, which means your video card is running by 8 and that secondary slot is running by 8. Not ideal, but that's what's available, so I'm just saying. Then you also have one PCI Express 3.0 by 16 slot that's running at 4X mode. So you think of it this way. I've got one 16-lane slot, I've got one 8-lane slot, and I've got one 4-lane slot. If I looked at just these two motherboards on that chipset, and remember you change one thing, changes everything. If I looked at that one chipset on these two motherboards, for this I would go with the Asus and I'd go with this motherboard over that Gigabyte board based on PCI Express resource allocation. I'm just saying. So now let's take a look at the next link. What I want to do is show you and help you to understand why, from my perspective, based on resource allocation and the resources we are fussing over now, there was a time we used to fuss about IRQs. That was a big deal. For those that remember that, it's a long time ago. There will come a day where we won't be fussing about PCI Express resources. But that's the game right now, and that's what we're dealing with. So what I want to show you now is if we go to a high-end desktop, specifically, how can we make it affordable to build an X399 chipset-based computer motherboard? That's what we're going to look at. Okay, now here's where it's important to make the distinction. We were looking at a B550 for a motherboard that was going to cost, what, a couple $100. Now we're looking at a motherboard that's going to cost us $250. So we're talking a $50 difference. How big is that? Okay, going forward, if you want to upgrade, you've got the resources on the high-end desktop of the X399 because you have 2 16-lane slots and you have 2 8-lane slots and whatever else is down the line. That's true with all the X399. That's also true on the X299 for Intel, and that's also true on the TRX 40 if you decide to build a Threadripper 3. So 2 16-lane slots, 2 8-lane slots, and whatever else follows. So that's enough room that you can upgrade and put in something like, say, an Asus quad card that has bifurcation. And if you go with a card that one needs the slot and two needs bifurcation, you've got to go in with a high-end desktop. If you got a machine like a 550 or the 570, you may have the slot, but you don't have bifurcation. And I can show you some stuff with bifurcation that Gigabyte's done on the 550 that makes a whole lot of sense, but doesn't make any sense when you start looking the way they've divided that slot up. You don't get 4, 4, 4, and 4. You'll get like 8 and 2 4s or 2 4s and 8, which makes no sense at all. So unless they know something we don't know, they need a BIOS update to fix that so that you can put a generically 4x4 by 4x4 card in there, which is what's required to put 4 NVMe drives on one card that's $50. Okay, a $200 motherboard versus a $280 motherboard. So if we built the 550, $200 motherboard. If we built the X399, we're looking at a $280. That's $80 more. If we built on the 550 with $200, that card with bifurcation is about another $300. So 200 plus 300, that's $500. Whereas if we go this way, we spend 280 plus 50. I'm just saying, do the math. Initially, it may cost more, but down the road, it's going to be less expensive. The most important part is your motherboard with your chipset. That's the foundation for everything you're going to do that you can grow with, that you can go on and do whatever you want with this stuff. And if you want everything on the board with all the whiz bang, which would be to add one of the NVMe cards that does 4 drives and to also add a Thunderbolt 3 card, then I would suggest a TRX 40. We will do another video about building a TRX 40 at another time, but right now, because of what's been released with chipsets and what's going on, we thought it very, very relevant to get into this with you now and to share this with you. I want to continue on this because we're not finished, and I want to help make the case to understand a high-end desktop and why I think you can afford it. So stay with us. So now what we're going to do is go to the next link, and the processor, if you were to go look at the Threadrippers, and I'm just going to cut to the chase here with a link into the PCPartPicker system builder, and I would suggest for the money, we're looking at a 1920. Now that's 12 cores. The price jumps significantly for the Threadripper CPU when you jump to one of the newer processors that has more cores and more threads. This gets you on the platform. Remember, you can still do all this other stuff with all these add-in cards, and you can go with this processor and get bang for the buck. And that's what we're all about. Build a high-end desktop that's bang for the buck. Build it with a 1920. Watch the prices on all of them. And if somebody does a sale, because sometimes you'll see a deal where if you buy the motherboard and you buy the processor together, they'll knock off an X amount of dollars. Watch for those kind of deals. So those two items, your motherboard and your processor. Then we got RAM to deal with, but let's finish the processor first. So if we were to look at this processor, we're looking at $300 for the CPU. $300 for the CPU, that's reasonable. What are one of these new other processors cost that work on the 550 chipset? You're kind of a wash on the price of the processor. So I'm just saying, look at the zoom in and zoom out. Look at the totality of what you're trying to do. Because if you build a high-end desktop, you're going to be head and shoulders ahead later when you start saying, what can I do to upgrade? Now, if you build with the B550 or the X570, that's dual channel memory. If you build with a Threadripper, 1, 2, or 3, that's quad channel. Now, we're going to look at the manual on one of these boards, and I want to drill in and show you how much RAM you have to have or how small of an amount of RAM you can get by with to get that thing up and running, and that's what's important. Remember, it's all about bang for the buck, getting on the platform, and something you can grow with later. So let's consider our options. Now, as we look at the processor, let's go back and look at the motherboard. The X399 AORUS Pro, this is a Rev 1 board. I don't want to just go into the features. I'm going to go to the support. I'm going to download the manual, and I'll do a search for PCIe, and that takes us right to this. And if you'll notice, 1, 2, 3, 4, 5. Now remember, even though there's 5 slots, there's not 5. There are 5 mechanically by 16, but electrically, 2 of them are 16 lane, 2 of them are 8 lane, and the other could be probably a 4 lane. It's just the way the resources work out. But this is a good board. It's bang for the buck. We haven't built on it, but this is what we'd recommend for a high-end desktop to get you on the platform. Now let's look at the memory. That's the next big point I want to make. So, okay, we're talking quad channel memory. So we'll have 4 slots on the left and 4 slots on the right. Now what's important here to make the distinction is how that memory sets up and the cooler you're going to use. Because, these 3 things, RAM, motherboard, and processor, make the machine, but you're going to have a cooler That would be item number 4. So let's look at the memory, the count we're going to need. Let's consider our options. Then we'll go look at the CPU cooler we're going to recommend, which is the one we've been building with, which is, our motto is, number 1, bang for the buck, but number 2, let's keep it simple. So, okay, this board will support 128 gigs of RAM. So what we want to look at is the chart for the memory. There we are, there's the chart. Okay, now this is important because this is going to show us 1, 2, 3, 4, all the way up to 8 modules. Now this says you can get the machine running with 1 module, but to be on dual channel, you'll need 2 sticks. Now what we're going to suggest is whatever you put in those 2 sticks, put in something you can grow with, not something you have to take out. In other words, if you got 8 slots and you say you might want to go to 64 gigs of RAM, what does it take? 8 times what to get to 64? 8 times 8, okay. If we're looking at 8 times 8 to get to 64 gigs of RAM, then I would suggest for those first 2 modules, buy a kit that's got 2 8-gig sticks, which is 16 gigs. That's dual channel, but it gets you up and running. Now, once you've got to that point, instead of 2 sticks of 8, to go 2 sticks of 16, or if you stick with the 2 sticks of 8, see what it'll cost to go 4 sticks of 8. So you look at the math and see what's possible. So if all we need are 2 sticks, and it's specific on the slots and where they go, and this shows us with 2 modules, we need to be in DDR4 underscore 2A, which would be second from the right, and DDR4 underscore 2B, which would be 4th on the right. It's very, very important where that memory goes. To me, it almost is like the memory is counterintuitive to the machines we used to build that we've been building since we've been building computers. But you got to follow the specs according to what they tell you, or else that thing's not going to post. And when a computer won't post, that's a real bummer. The other thing that can cause it not to boot correctly is if the processor is not torqued down correctly. So you got to use the torque wrench that comes with the CPU. And once you hear that click, you know you're good to go. When you hear the memory go in, you know it clicks, it's good to go. But it's always good to double and triple check it. So we can do 2 sticks of memory. Let's look at the RAM, and I'll show you the RAM why. The memory we would go with for Corsair Vengeance, this is low profile RAM, and the reason for low profile, everything just fits so tightly that we have shown, if you've watched our builds, where we now have built 2 Threadrippers, and we're going to be building a Threadripper 3 real soon as we can get to it. We've already built one over the phone. That's another discussion we'll get into later. For this, to build an X399 chipset, if you can get the least amount of RAM on there possible, let's see what that RAM costs. Now we're looking at Corsair Vengeance, low profile memory, 2 8-gig sticks. It comes in 3 colors. Check. Sometimes there's a price variance. Look at the black, the red, as well as the white ones. I like the red ones, but that's just me. The price right now is $75. Okay, here's a point of distinction I want to make. If I can get 2 sticks for $75, what would it cost for 4 sticks? Logically, you would think it's $150. But what if those were 2 sticks of, say, 16? So do the math, check, compare, and see what you're going with. But this would be the least amount, because with 2 sticks of 8, if I've got 8 slots, 8 times 8, 64, I can get to 64 gigs if I'm using 8-gig sticks. If I want to get to 128, then I've got to do the math. So as I look at what I'm working with based on RAM, motherboard, and processor, the next thing I have to have will also be a cooler. Now we're going to add our 3 components, which will be motherboard, CPU, and RAM. Then we'll pick a cooler. Then we can do the what if, and it'll show us the total. Okay, we're looking at the motherboard. So the Gigabyte X399 AORUS Pro, we'll add that. We need to choose a CPU. We'll add that. We're looking at a 1920 based on the price. I mean, with your processor, you're spending the same amount of money for the processor, so you might as well get the processor that's supported on a better chipset. And I hope you can see and understand and distinguish that difference. Bang for the buck. So we'll add that CPU. Now it shows a list for compatibility. The reason it's showing that, which is really nice, is because there's no CPU cooler on there, and it's going to tell us we need a cooler. We'll get to that, but right now I want to pick the RAM so we can show you where we're at. So of the RAM we're going to look at, based on what we just picked, we're going to choose memory, and cutting to the chase, we're going to go with Corsair. We need 16 gigs, which would be 2 8-gig sticks based on the rating. So if we add that, that's $75. Now if we were to go with, say, more memory, this will accurately tell us if we were to say, and right now we're not messing with Samsung B-die, we're not messing with high performance memory, we're just messing with memory that'll work in this machine that's compatible so we can get this thing up and running to get you on the platform. If you want to get into some of that kind of stuff that kind of gets kind of esoteric, you know, we can do that, but it's going to be at a premium. Right now, we're not talking premium. We're talking high-end desktop, bang for the buck. So going with that amount of memory to get you on the platform, that now has us at $299 for the processor, $280 for the motherboard, $76 for some memory. So we have a Threadripper 1920 processor, 12 cores, 24 threads. We've got a Gigabyte X399 AORUS Pro motherboard for $280, and we have Corsair Vengeance low profile memory. Okay, what's important is everything as it fits together, and as we showed in our videos, once that memory goes in there, that cooler is going to sit right over the edge if you were to fill all the slots. If you don't fill all the slots, the way the memory goes according to the first two and the second two, they'll be just out of range of that. And the way the cooler that we're going to show you sits on there, you can take the fans that are on the side, of which there's one stock fan, and you can slide it up just a little bit so that RAM can slide right underneath there. But what we do is put the secondary fan on, which is a little bit more money, that raises that up, and that RAM still fits. And that's if the theory goes that you want to put all the RAM in. So I'm just saying, you know, change one thing, changes everything. So as we look at our specs right now, based on our price, we'll go down here to the total. Okay, right now, $655.96. You know, do the math, not bad, $700. Now, that's only my three main components. I've got to add a cooler, that's going to add another $80. And I'm going to show you the one we use. And again, for the reasons we've just talked about, keep it simple. So we'll go up here to a cooler. There's lots of coolers to pick. You know, we've done the liquid thing. We tried it on a Ryzen. That was like building a Swiss watch. Done it, not going to do it again. It's interesting, it's curious, but keep it simple. And we're going to recommend a Noctua cooler if that's what we're going to show you. Now, Noctua has three coolers. So what we'll do to cut to the chase, over here on the left-hand side, we're going to pick the brand, Noctua. This will immediately take us to these three coolers. Now, if you're interested in looking at the coolers, you can drill down and see the difference. I'll just cut to the chase and tell you the one we're going to recommend. If this were going in a rack mount case, you would have to have a 5-unit rack mount case. If you need a 4-unit rack mount case, which is practical and logical, then you'll need a different cooler. But the one I'm going to show you would require a 5-unit rack mount case. So, little tidbit. It'll be the one on top, which is the Noctua U14S. I believe the U9 is the one that fits in 4 units, a 4-unit rack space. So that's $80. We're going to add that. We now have our 1, 2, 3, 4, 5 main components: RAM, motherboard, processor, and a cooler. What's number 5? Case is coming really nice, but that's something else we can pick. But I want to show you the main components that we want to go with, and this is the place to do it from, PCPartPicker. So right now, our total, we're looking at $735.86. For those of you that are thinking about upgrading, remember this is DDR4. If you've got DDR3, that's not going to work. If you've got a case, we're looking at a standard ATX motherboard. Some of the stuff we're going to be doing later when we look at if I were going to build the TRX40 motherboard system, we're going to be looking at some XL ATX cases, which is a whole other animal. I don't like the choices we've got, but we're going to go through what we thought were the best and make some choices and show you what we like about them, what we don't like about them. But I got to tell you, everything I've seen so far, for the most part, 3 of them are a beast. I mean a beast, which is kind of crazy. The case we may end up using is not my favorite case, but it's like we're getting low on options. But that's another issue. So if you're interested in building a machine, this will get you started. And what we wanted to show, what's necessary. We're looking at bang for the buck. So again, if you're building new, you still got the other components to get. You're looking at a power supply, about 750 watts. I'll show you. I've mentioned 2 brands. Other stuff that we add, the case, depends on what's going on right now. And I can tell you right now, cases, I don't know what it is with cases, but they're losing functionality. They're going more for aesthetics. I'm not into the form. I want function, because I need a machine that performs, you know, especially if it's for work. And I think all of us are kind of needing something that's more functional. And if we're doing laptops, we're going to be doing some more of that later. But this right now is about if I were building, what I would build and what I recommend. If I were building a new computer, I would build an X399 high-end desktop, because it's bang for the buck to get on the platform. Because once you're there, then you've got room to upgrade and you've got options. I can't tell you how many people, you can look at the video on the Asus HyperQuad card. That's had over 60,000 views, and so many people want to put that in their machine, they don't have the resources for it. And I don't mind looking. I'm happy to do it, because I can tell you, as I've always said, the more I learn, the more I realize how little I know. It's just, as soon as you have something figured out, it changes and we go on to the next thing. So I hope you've enjoyed this. This is Builder Buy. My name is Gil Boyd. We've got some more stuff coming. We're going to be looking at some more M.2 NVMe cards. We're going to be doing some more build specs on if I were building a Threadripper 3. Thanks for joining us. I hope you enjoyed this. We would appreciate if you'd subscribe. Thumbs up would also be appreciated. We look forward to seeing you in the next video. And that's a wrap.